Hi, and welcome back to lecture 14 of the course Electrical Systems in Agricultural and Biosystems Engineering. And the topic is still on wiring, or determining actually the size of the wire of the of for the um, electrification, okay, the conductors of certain farm applications, of specific farm applications. Now, in the wiring, okay, of um, or wiring diagrams, okay, there is always a resistance to the wire, okay, given that there's no perfect conductance or the travel of electricity through a given circuit. And in reality, okay, the degree of conductivity of a material usually falls into just a spectrum. With if one recalls the chemistry, metallic materials have electrons, okay, that are free and conduct electricity, and thus are termed as highly conductive. And it just goes to show, okay, that electrical conductivity is the degree of how electrons easily flow through a material. Naturally, all materials have a certain degree of insulation, okay, or resistivity, and that limits uh, the electrical conductivity of that material. Now, this is the very reason, okay, materials physics is after superconductors, because these are, well, it limit, or at least it very limits the losses of electricity, okay? Depending on the wire material, okay, therefore there is um, a resistance to electron flow, and this has been found to be proportional to the length, okay, of the path, okay, in that circuit, and inversely to the cross-sectional area. Okay, this is shown as equation number 1. Okay, where you have the length in centimeters and the resistivity. Okay, this is the proportionality concept, and it's in ohms centimeters, and the cross-sectional area is in centimeters squared. Now, the different resistivities of different materials are shown in table 1. Okay, and different metals. Okay, these are different metals, okay, at a reference temperature of 20 degrees Celsius. Now, usually this would change, okay, and there's a way to determine the resistivity. Now these values are used now, okay, the resistivities are used to in this equation number 1 to determine the specific resistance of a certain material, okay, in a certain application. Now, to determine the voltage drop and wire resistance, okay, first it is important to compute the resistance, and then next is to compute the equivalent voltage drop, and then you compute the equivalent power requirement, and sum up the power requirement with actual loads, and lastly to determine the ampacity rating by dividing the total power requirement by 240 volts. And there's a sample computation, okay? The wire, okay, ampacity, and the length of run and wire size. And well, for different materials, okay, you have the length of run in meters, okay, and the specific ampacity ratings to be determined, okay, for a specific wire, okay, wire type. You have copper, aluminum, and then copper. And this is from a certain manufacturer. Okay, voltage drop, okay, it becomes important when the length of a run wire, okay, run of wire, okay, sorry, the run of wire or cable becomes very long, okay, And usually this is not a problem in circuits within a building, okay, or a farmhouse. But many this becomes an issue, okay, when running wires, okay, to an outbuilding, okay, to a well pump and others, okay, and also for very long distances. Now, excessive voltage drop, okay, can cause loss of efficiency in operation of light, okay, lighting, motors, and even appliances. This could result in the lights to dim, okay, so brown out in the motors or appliances with shortened life, okay. Now, to avoid the excessive voltage drop, okay, it is important to select a size wire that will minimize voltage drop, and it is important to know the length of the wire run and the load, okay, and this is where this table comes in. Now, to determine the load, okay, add up all the wattage of all electrical devices that will be on the circuit and divide this total by the voltage of the circuit, usually 120 volts or 240 volts. If it's bigger for a three-phase, then do so, okay? Now, the tables assume still conduit, a power factor of 0.9, and the ambient temperature is 86 degrees Fahrenheit, and no more than 3 current carrying conductors. Now, for specific manufacturers, there are specific tables that can be used, and this is from Serowire, okay, in 2020. Now, let's talk about phantom loads. I think I've turned off my wait. Okay, so let's talk about phantom loads, and this is well connected to wiring, okay, because well the conductance or the flow of electricity is facilitated by wiring. So phantom loads. So we're not talking about that phantom. Okay, what we mean by phantom loads are, okay, the electronic and electrical devices that are consuming electricity, okay, even when turned off. So I'll turn on my video now. Okay, so why it's important to take note of this, because okay, even while this equipment, okay, or appliances are turned off but still plugged to the outlet, okay, this can be consuming electricity, and it's important to unplug them, okay, when not using this electronics or appliances. For example, if one is not charging a cell phone, okay, or other battery operated device, unplugging from the charger wall is important, okay. Now, or unplugging the charger, okay. Now, use of power strips that allow one to unplug several electronics by flipping a single switch, okay, it's another good practice. And then there's also right here. So this is where the what's to take note with phantom loads, okay. So there are devices that are always in standby mode, and these are consuming electricity. Why? Because they have to power those circuitry, the boards that are allowing them to go in standby mode. There are also other devices that are still functioning even while turned off. Okay. Devices with instant on functions, okay, take note of them. They should be disconnected, or otherwise, if it's for example security, then why it has to be turned on forever. There are also transformers converting the voltage and other transformer types, and these are causing electricity losses, okay, phantom loads. Programmable devices such as thermostats, those are phantom loads as well. Okay. In the next lecture, okay, the topic is on lighting, and thus I'll say that it's been a while, and thank you for listening, and I'll see you in the next lecture.